Modernage MCQs, Physics class first year, unit number 5, Rotational and Circular Motion, part 6. A sphere of mass m, radius r, rolls down from the top of an incline with the height h. The linear speed of sphere at the bottom is option A, gh square root, option B, 4 by 3 gh square root, option C, 10 by 7 gh square root, option D, 7 by 10 gh square root. The key is 10 by 7 gh square root. Therefore, the correct option is C. Reason: at the top, sphere has potential energy is equal to mgh. As it rolls down, its potential energy is converted into kinetic energy. Therefore, mgh is equal to 1 by 2 mv square plus 1 by 2 I omega square, which is equal to 1 by 2 mv square plus 1 by 2 into 2 by 5 mr square, which is the moment of inertia of the sphere, into omega square r. mgh is equal to 1 by 2 mv square plus 1 by 2 1 by 5 mv square. M is cancelled throughout the equation. Therefore, gh is equal to 1 by 2 v square plus 1 by 5 v square r. gh is equal to 7 by 10 v square r. v is equal to 10 by 7 gh square root. Hence, the speed of sphere at the bottom is 10 by 7 gh square root. A disk, a hoop, a sphere rolled down from same position on an incline. Which one reaches the bottom first? Option A, disk, option B, hoop, option C, sphere, option D, cylinder. The key is sphere. Therefore, the correct option is C. Reason: at the bottom of incline, the speed of solid cylinder or disk is Vd is equal to 4 by 3 gh square root. The speed of hollow cylinder or hoop is Vh is equal to gh square root, and the speed of sphere is Vh is equal to 10 by 7 gh square root. Therefore, Vs is greater than Vd is greater than Vh. Hence, the sphere will reach first at the bottom. When you wear a body in a vertical circle at the end of a string, the tension with respect to you is maximum at option A, top, option B, bottom, option C, right, option D, left. The key is bottom. Therefore, the correct option is B. Reason: at the top, centripetal force is Fc is equal to Tt plus mg, or Tt is equal to Fc minus mg. At the bottom, centripetal force is Fc is equal to Tb minus mg, or Tb is equal to Fc plus mg. At the right, centripetal force is Fc is equal to Tr plus 0, or Tr is equal to Fc. At the left, centripetal force is Fc is equal to Tl plus 0, or Tl is equal to Fc. The tension in the string at the top is Tt is equal to Fc minus mg. At the right and left is Tr is equal to Tl is equal to Fc, because the contribution of weight in tension is 0. And bottom is Tb is equal to Fc plus mg. Therefore, Tb is greater than Tr and Tl greater than Tt. Hence, the tension is maximum at the bottom. The centripetal force acting on a body of mass m moving in a circle of radius r with speed v is option A, minus mv square divided by r into r vector, option B, minus mv square divided by r square into r vector, option C, minus mv square divided by r square into r unit vector, option D, minus mv square divided by r cube into r vector. The key is minus mv square divided by r square into r vector. Therefore, the correct option is B. Reason: the outward radial unit vector is positive and the inward radial unit vector is negative. The centripetal force is radially inward. Therefore, Fc is equal to mv square divided by r into minus r unit vector, which is equal to minus mv square divided by r into r unit vector. Now putting the value of unit vector, we have minus mv square divided by r into r vector divided by r, which is equal to minus mv square divided by r square into r vector. Hence, the vector form of centripetal force is minus mv square divided by r square into r vector. The centripetal force acting on a body of mass m moving in a circle of radius r with angular speed omega is option A minus m omega square r vector, option B plus m omega square r vector, option C minus m r omega square r vector, option D plus m r omega square r vector. The key is minus m omega square r vector. Therefore, the correct option is A. Reason: the outward radial unit vector is positive and the inward radial unit vector is negative. The centripetal force is radially inward. Therefore, Fc is equal to mv square divided by r into minus r unit vector, which is equal to minus m r square omega square divided by r into r unit vector, which is equal to minus m r omega square into r vector divided by r, which is equal to minus m omega square r vector. Hence, the vector form of centripetal force is minus m omega square r vector. When a mass is rotating in a plane, its angular momentum is inclined at option A 120-degree plane of rotation, option B 90-degree plane of rotation, option C 60-degree plane of rotation, option D 30-degree plane of rotation. The key is 90-degree plane of rotation. Therefore, the correct option is B. Reason: the angular momentum L vector is equal to R vector cross P vector, where P is the linear momentum, which is equal to M into R cross V. Therefore, vector L is perpendicular to R and V of the plane of rotation defined by R and V. Hence, the angular momentum is at 90 degree to the plane of rotation. A flywheel rotates at 6,000 revolutions per minute. The angular displacement of its shaft in 1 second is option A 600 pi radian, option B 400 pi radian, option C 300 pi radian, option D 200 pi radian. The key is 200 pi radian. Therefore, the correct option is D. Reason: for a rigid body, the angular velocity of flywheel and shaft is same, that is omega is equal to 6,000 revolution per minute, or omega is equal to 6,000 pi radian per 60 seconds, or omega is equal to 200 pi radians per second. The angular displacement of the shaft in 1 second is theta is equal to omega t, which is equal to 200 pi radians per second into 1 second, or theta is equal to 200 pi radian. Hence, the angular displacement of its shaft in 1 second is 200 pi radian. To produce an artificial gravity in a satellite of radius r is rotated with frequency f given by option A 2 pi g divided by r square root, option B 1 by 2 pi into g divided by r square root, option C 2 pi into r divided by g square root, option D 1 by 2 pi into r divided by g square root. The key is 1 by 2 pi into g divided by r square root. Therefore, the correct option is B. Reason. For artificial gravity, the satellite is rotated with centripetal acceleration AC is equal to R omega square, which is equal to G, the gravitational acceleration. Rg is equal to R into 2 pi divided by T whole square, which is equal to R into 2 pi F whole square, which is equal to R into 4 pi square F square. Rf is equal to 1 by 2 pi into G divided by R square root. Hence, the satellite of radius r is rotated with frequency 1 by 2 pi g divided by r square root eagle with the extended arms is rotating on a turntable. When she stretches arms in, the moment of inertia, option A increases, option B remains same, option D decreases, option D becomes zero. The key is decreases. Therefore, the correct option is C. Reason. The moment of inertia depends on the mass of the body and distribution of mass about the axis of rotation as I is equal to sigma mr square. In the case of extended arms, the R increases. The increase in R increases the moment of inertia I. Therefore, in the case of stretched arms, R decreases and I also decreases. Therefore, moment of inertia decreases when she stretches arm. Hence, the moment of inertia decreases. Eagle with extended arms is rotating on a turntable with angular momentum L1. When she stretches arms in, the angular momentum, option A L2 is less than L1, option B L2 is greater than L1, option C L2 is equal to 0, option D L2 is equal to L1. The key is L2 is equal to L1. Therefore, the correct option is D. Reason. According to law of conservation of angular momentum, L is equal to constant. Therefore, the angular momentum with the stretched arms is L2 is equal to the angular momentum with extended arms L1. Hence, L2 is equal to L1.